This is zoomed in on mooring line 1, which goes from an anchor on the seabed, the brown line, up to this point here where it's connected to the magenta colored object, which is the float. And then I've made the anchor mooring line chain, the 0.75-inch chain. I've colored it green and made it slightly thicker. If we look at what that mooring line is made up of and its structure is made up of 0.75-inch chain for 25 feet and then 2-inch nylon for 90 feet. One end, the top end A, is attached to a 6D buoy called 6D buoy 1, and the other end is attached to anchored. The coordinates of the anchor is given, and I've attached it to the center of the 6D buoy, which is in the corner of the object. So the attachments on the line is just one, this 30-inch float. It's attached at 25 feet from end A, which is where the chain ends. And the attachment type, it's a 30-inch float. It's colored like that. It's got a width of 7 on just the drawing. Its geometry, it's got a mass of 0.079 kips or 79 pounds and a volume of 8.1 cubic feet and a height of 2.5, representing its 30-inch diameter. So as it wants to float above the water or below the water, its varying depths or amount of submergence will be changing its buoyancy. And when fully submerged, the full height's submerged, and when it's in this picture, it's mostly emerged. It's offset from the line 1.25 feet to represent the mooring line attaching at the bottom. Then the line types, the chain and wire and nylon. No, there's no wire, there's nylon. If we look at the nylon, if we look at the geometry and mass characteristics, we model the diameters of each line. We've got a special way of modeling chain to pick up its drag properly. We model the structure, so we have a bending stiffness which is 0 for those two lines, and an axial stiffness and a Poisson's ratio. Then we have added mass coefficients for accounting for the wave loading and motions, and we've got drag coefficients.